Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GHEtool Cloud. And today we will be talking about the concept of thermal interference between different boreholes, different bore fields, and more specifically on the new module in GHEtool Cloud that helps you calculate exactly that. I promise you it will be an interesting video, so let's jump right into it. Now imagine we have two streets where there are different residential buildings. We have already 3 people that have installed a ground source heat pump, and we receive a call from the person living here at the intersection between the 2 roads. They ask us whether or not we can design a bore field for their house as well. So what we do is we fire up GHEtool, we fill in the ground parameters, we make our design, we fill in our building demands, and we end up with a temperature profile. We make sure it sticks within certain limits, and we can make our official offer. We can say, well, this is the amount of drilling borehole meters you need. Now, of course, that does not take into account the fact that there are neighbors here. And imagine that this left neighbor, this blue neighbor, that his project has a heating dominated building, and they extract more heat from the ground than they inject. So over the years, 25 years, the ground around this borehole will be cooled down because the heat has been extracted due to the imbalance. And the closer you are to this borehole, the lower the temperature will drop over time. But it's not only this blue borehole, also the borehole on the right and on the bottom can have the same behavior. Due to the imbalance, the ground will cool down around this borehole. So our project, in the middle of all these other projects, will experience a temperature drop of 0.5 degrees Celsius due to the pink, 0.5 degrees Celsius also due to the blue borehole, and 1 degree Celsius due to the orange one. So our design, where we said, okay, we make sure it stays within the limits, now our fluid temperature over the period of 25 years will be 2 degrees lower due to the fact that we have neighbors. So this is really important to take your neighbors into account when you're drilling in a densely populated area where there are already bore fields or boreholes installed in proximity. And that's why in countries like the Netherlands, where there are quite a lot of individual geothermal installations, and in Stockholm, there's actually legislation for this thermal interference. And this is a print screen from a tool from the Netherlands, which is GHEtool. This is basically a database of all existing individual or collective geothermal systems. And all the yellow dots you see here is actually a geothermal borehole. And as you can imagine, the people living in the center of this project, they will actually experience quite a lot of thermal interference due to all these neighbors. And this can easily range in the order of magnitude of 2 or more degrees Celsius. So it's really important to take this into account when you're designing your geothermal system. Now, how can you calculate this thermal interference? Now, basically there are 2 different models for that, the infinite and the finite line source. Now, we already touched upon this when we were talking about the G functions and the long-term behavior of our bore fields. If you have not watched the video, it's linked in the description. But what we said is basically, since our borehole diameter is way smaller than its deep, we can assume it is a line. And then we can assume it's an infinite line, so it will go on forever. That's the most conservative way of simulating boreholes, and it's accurate to a reasonable degree for boreholes that are far apart or boreholes that are really deep, 400 or 500 meters, let's say. Now, our finite line source, it's the most accurate one because it can take into account finite depths. So if you have interfering boreholes which have different depth or which are close together, it's better to go for the infinite line source model. Now, before we talk a little bit more about them, I just want to say that in this calculation, we assume that every bore field is modeled as a single borehole. So this means that if you have 2 boreholes, or 3 or 4, that you have to center your equivalent borehole, let's say, at the geometric center of the bore field. Now, when you have 20 or 30 boreholes, of course, this is no longer accurate because the distance, the radial distance between your geometric center and the edge of your bore field will be too big, and there will be inaccuracies. And research by Groen Holland in the Netherlands has found that this assumption is reasonable up to 6 boreholes. So imagine you have 6 boreholes, you have an equivalent borehole in the middle here. But this you will see in GHEtool later this video. So let's talk a little bit more about the different line sources. So when you have an infinite line source, there is no variation in depth, or there is no vertical variation, so you can just take a cross-section and make the problem a 2D problem. And that's exactly what you see here on the right. So you have a borehole, and the further you go from this borehole, the lower your, or the less your thermal interference will be. And this is governed by the equation here. I will also pop up the different meanings. So what you see is the thermal interference. It depends on the radius. The further you are, the less influence you will see, and also in time. The longer you wait, the more influence there will be. And this is equal to the specific heat extraction rate. So if your borehole has 10 watts or 12 watts of heat extraction, that makes difference in how the ground cools down. Your thermal conductivity as well. The higher conductivity, the better your ground can cope with this imbalance because heat can be transferred more easily. This is multiplied with the integral function, where we have the square of our radius, the volumetric heat capacity, and this is divided by 4 times the conductivity at the time. This equation is not that important, but what is important is to know that the longer you wait, the bigger your influence will be. The closer you are, also the bigger your influence will be. Now for the finite line source, the story is a little bit different, because here imagine we have 2 boreholes and each of them has a different depth. And with this finite line source, we can actually take this into account. Now the equation is way more complicated. We will not discuss this, I promise. But I want to imagine the following with you. So imagine both boreholes have the same specific heat extraction of 10 watts per meter. Now in our case for our infinite line source, where we had our 2D problem, or 2D assumption, basically the thermal interference from borehole 1 to borehole 2 is the same as borehole 2 to borehole 1, because they have the same specific heat extraction. Now for the finite line source, this is not the case. And this is reasonable, because if you say, well, this is borehole 1, and borehole 1 is bigger than borehole 2. But of course their specific heat extraction rate is the same, but since this one is bigger, the influence of borehole 1 on borehole 2 will be bigger than the other way around. So this is something you can take into account with the finite line source assumption. So enough theory, let's jump into GHEtool Cloud and show you how you can actually simulate your first thermal interference yourself. So here we are in GHEtool Cloud. I just created a new project, and as you can see, there is here a new button to calculate the interference. Let's go ahead, click on that, and it will open up a new tab here for the interference calculation. Now, there are some general settings you have to enter for your before you can actually calculate the interference, which is the conductivity of the soil, because depending on how good your soil conducts heat, this will have an effect on your interference. You have the simulation period, after how many years you want to calculate the interference. You have the volumetric heat capacity of the ground, and you have your maximum allowed interference. Now, this last one is not used in the calculation, let's say, but for example, in the Netherlands, there is a legislation that say, well, you cannot allow more than 1.5 degrees interference, and this will make sure that in the end, when you do the simulation, this will pop up in red when this threshold is crossed. Now here, you have to enter all your systems. So what we need for each system is whether it's a new or an existing one. the X and the Y coordinates, your total system length and your borehole depth. Now this relates to what I said before. When you have one borehole, of course your borehole depth and your total system length will be the same. But if you have two boreholes of 100 meter, you have to say, well, your total system length is 200 meter, your borehole depth, it is 100. And based on that, it will know that there are two boreholes and your equivalent one will be centered at position X and Y. We have our yearly demand in heating and cooling and our seasonal performance in heating and cooling. Now you can edit from a CSV file, but you can also edit manually. So you say, okay, we have a new system here at position 0, 0, let's say it's 100 meters in length, 100 meters depth, so it's a single borehole. And then let's say our yearly heating demand, let's say it's 12, and our yearly cooling demand, let's say it's 3. Let's save this. So we now have our first line. Let me go ahead and duplicate this. And let's say it's 12 meters apart. Let us now make a double system with two boreholes. So we're going to say our system length is 200 meters, for example, 100 meters deep. And the middle borehole is located at, let's say, location 12.3. Our heating demand will, of course, be slightly bigger. Let's make it 20 megawatt hours a year and a cooling demand of 5, for example. Let's go ahead and save this and calculate this interference. So this will send it to the server, and this is the interference you see. You see here an interference map, which is not that interesting when you have only two systems. And here you will see the interference. So due to the average heat extraction of system 1, system 2 will experience a temperature drop over 20 years of 1.03 degrees Celsius. System 2 will make system 1 drop 0.62 degrees Celsius. So that's how you calculate this interference. Now let us go ahead and show you one important feature for the Netherlands. You can also couple this to the GHEtool tool. So if you, for example, say, well, we have a project in the city of Maastricht, we can go to for example, this neighborhood, and we can click on a location. Here we see we have all these projects, and we just import the 12 systems. It will warn us that there are already systems. You can either add them or you can override them. Let's override them. And here we have all the boreholes imported. Now, what you will see here is that there are some projects that we imported in which there are more than 6 boreholes. So we have here total system length of 6,700 and a borehole depth of 130 meters. So here there are more than 20 boreholes. So this we cannot take into account. Let's move that away. And I think this is a typo in the database. Let's go ahead and change it to 140 as well. Now we have our system loaded. We can calculate that, send it to the server. And this is the result we end up with. You see here our interference map, which is now more interesting than before, where you can see from system 3 to 1, there is, for example, a drop in temperature of 0.32 degrees Celsius. And here you have your whole table with the interference from each system to the other system, and then below your total interference degree. So I hope you found this video interesting. You can export this to a CSV. Of course, it's all integrated in the automated reporting as well, with the explanation of the physics, whether you use the finite line source or the infinite line source. If you have any questions, please ask me, send us an email if you have demands for new features that are interesting in your region, or you want to have us implementing all the databases that are relevant for your projects into the tool. Let us know. We're more than happy to investigate all of that. And I hope I see you in the next video. Take care. Bye.